All right, ladies and gentlemen, this is your homework for January 13th, 2016. The first thing we're going to go through is calculating wavelength, which is a review. We know that wave speed equals wave frequency times wavelength. We can rearrange that formula to get frequency, which is frequency is speed over wavelength, or we can rearrange it for wavelength equals speed over frequency. There are different options. So here's your sample problem. You and your partner sit on the floor and stretch out a coiled spring to a length of 3.5 meters. You shake the coiled spring so that the pattern has one antinode between the two of you. Your partner measures the time for 10 vibrations and finds out that it takes 24 seconds for the coiled string to make 10 vibrations. So the first thing that I'm going to do for this problem is I'm going to go ahead and draw a picture of this particular spring. So I know that there are 10 vibrations, which means that that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, obviously, this is not the prettiest picture because I'm drawing it on my computer. My point that I want to show you, though, is that what we need to make sure we know is to draw a picture for these type of problems, and then we can label what we need. So we know that the length is 3.5 meters. We know that if I shake it, the 10 vibrations that's going to go back and forth is 24 seconds. So there's a bunch of information there. So the strategy to figure out this answer is we're going to look here. We're going to draw a sketch of the wave that we made, and we're going to use this new formula that we're discussing, which is length equals the number of nodes times wavelength divided by 2. If I rearrange the equation to solve for wavelength, I know wavelength is 2 times the length of the string, which is 3.5 meters, divided by the number of nodes, which is 1. So the total is 7 meters. If you don't understand quite how to do that, I do want you to copy down this equation right here and understand that length is the length of the string, not the wavelength. Wavelength is going to be determined by 2 times the length divided by the number of nodes. Calculating amplitude. So to calculate amplitude, you're going to draw your midline and measure from that line to the top of the wave. That's right here. You'll just measure from here to here, and that's your amplitude. This is recorded in meters. To calculate frequency, frequency is the number of cycles per second. A full cycle contains both a crest and a trough. In other words, to calculate frequency, it's the velocity of the wave divided by the wavelength, or the number of wave cycles per second. So in that first example that we talked about, it says that there are 10 cycles over 24 seconds. So we would do 10 divided by 24 to get whatever that number is in cycles per second. For example, here we have 1, 2, 3 waves in 24 seconds. So I would do 3 over 24 because I have 3 waves divided by 24 seconds. So the number of waves in cycles per second is going to be 0.125 cycles per second. Next, if we calculate period of a wave, that's 1 over the frequency. So I know the frequency in this case is 0.125. If I do 1 divided by that, that's going to give me my period, which is 8. In other words, how much of a wave travels in 1 second. All right, next. To calculate velocity, you draw a sketch, you measure the wavelength here, you calculate the frequency, which is 1 over wavelength, and then you do velocity is wavelength times the frequency. So the example is the wave below has a period of 2 seconds, calculate the velocity of the wave. You guys can go ahead and print this out and measure it, and then the last thing you're going to do tonight is your homework. You need to look at the handout given to you in class today with the practice problems on it and calculate all the wave properties discussed in the video. Enter them on Edmodo in this format. Let me know if you have any questions.